Welcome to the SRA Plant-Rich Diet Task Force's program with the eminent climate scientist Gerard Bisshop. I'm Dawn Byford from the Rotary Club of Canmore in Alberta, Canada, along with my good friend Doug White from the Rotary Club of St. Thomas East Eco in the U.S. Virgin Islands, and many other members of our passionate Plant-Rich Diet Task Force team. The Environmental Sustainability Rotary Action Group, or SRAG for short, was formed to empower the 1.4 million worldwide members of the Rotary family to take actions to sustain our environment, particularly to stabilize our climate. The SRAG Plant-Rich Diet Task Force was formed in 2021. Transitioning to a plant-rich diet is one of the most impactful and delicious climate solutions any individual can take to help reverse global warming. We are also joined with many other task forces in SRAG, which we are proud to collaborate with. Mr. Bishop's Eating for Tomorrow presentation will highlight why it is critically important to significantly reduce emissions from the agriculture food system sector, especially emissions from animal agriculture, to maintain global temperatures below 2 degrees Celsius by 2100. He will also provide a brief history of his life's work, and at the end, his groundbreaking new research that will shed light and hope on how we can all simply and effectively work together to save our planet and ourselves. We are so honored to have Mr. Bishop here with us today to discuss this critical topic. He is the Executive Director of the World Preservation Foundation. He worked until mid-2010 as Principal Scientist with the Queensland Government Department of Environment and Resources Management Remote Sensing Centre, where he witnessed 4% of the world's deforestation for over 20 years. He also co-authored a book for the award-winning Eating Our Way to Extinction documentary and has produced a series of explanatory videos on climate impact of animal agriculture and co-authored a report on the environmental impact of Australian beef production. Following 37 years with federal and state government, Gerard is now engaged in communicating environmental issues such as deforestation, land degradation, and biodiversity loss, and is full of optimism that together, humanity and the natural environment have a bright future. He is definitely a person creating hope in the world. Thank you for joining us today. Gerard, it's such a pleasure. Over to you.
Yeah, thanks very much, Dawn. And it's a great pleasure joining you today and complimenting the wonderful work you do with SRAG. What I have today is the background, the science, if you like, behind the documentary Eating Our Way to Extinction. And I've been asked to include a short part of my background to give you an idea of what industrial scale deforestation looks like. So I'll do that to start with. So I'll share that screen initially. So this is from a short presentation I did recently, and I gave a bit of my background. So this is what it is. I was involved with government for 20 years, looking at satellite images of Queensland as well as other states of Australia. And we had a joint remote sensing program between the governments to monitor vegetation, to monitor tree clearing, and to monitor ground cover, in fact, for the graziers, to see for the grass that was there. So this is the government websites. These reports were freely available for and data freely available to download. And to give you an idea of Queensland, it's the top right corner of this picture. Queensland, the state of Queensland has the Barrier Reef running down the coastline, which you may have heard of. And the area of Queensland is the area of Texas plus New Mexico plus Arizona plus California. So it's a big state. The vegetation on that we were looking at ranges from, in the top right-hand corner, it's open savanna or open woodland, and the bottom right-hand corner, it went all the way up to a dense rainforest, but the average vegetation that we're looking at deforestation is pictured on the left of your screen, which had a basal area of about 8 square meters, if that means anything to any of you. And we crawled all over the state, not only looking at these images on satellite on the computer, but also in the field. And this is what we were looking for. We were looking for deforestation. Here's an example of recent deforestation where the trees are still lying on the ground. You'll see the process of that in a minute. The satellite data we got, it's now readily available. Anyone can look at these satellite data and compare themselves. There's good viewers for that. But over now 30 plus years of satellite monitoring, average 2,500 acres were deforested each day. That's about 10 square kilometres each day, actually 11. But that gives you an idea of industrial scale. And this is only our small corner of the world. This is Queensland, not Brazil, but the area is about half the area of Brazil. So 93% of that was for grass-fed industries, for beef and sheep production. And over the average over that 30 years, most of it was virgin forest. So this is, if anything can open your eyes to industrial food production the way we do it today, it's watching this. Of course, we all live in cities, so we don't see this stuff, but I'll give you an idea of what we did see. First of all, the satellite data. This is in the human visible range. On the left, you see the dark areas are the forests, and on the right, you can see the tracks still of the bulldozers where it's been cleared. In the near infrared and the mid infrared, we have other data from satellites that tell us a lot more about vegetation as well. That we actually had machine learning AI back then to map these areas. And of course, there's a reaction from the farmers in the bush. You know, stay out of my face, stay off my land. Most of the 3/4 of Australia is still Crown land. It's still owned by the government, but leased, and I believe it's similar in the United States. It's leased to the farmers, the graziers, for a 99-year lease with the expectation that it'll be just extended. And so really it's government land, but they still have a fierce protection of that land, you know, get off my land. So every now and then you see flashes in the media about the farmers' reaction to us. And of course, this sort of thing, you know, and I believe it's the same in the States. We were known as the tree police. So you get this whenever you turn up in a government vehicle unannounced in the bush, you're immediately targeted. In fact, one inspector lost his life recently from get off my land, that attitude. So this is what we were seeing. It's a video without audio, but I'll describe what's going on. This is central Queensland. This is the sort of trees that I spoke to you about. Some of these trees are 20, 30 meters tall. And if you have a big enough bulldozer like these ones, in this case are D11 dozers, you literally pull the trees out of the ground. I'll just start that video going. You have 2 bulldozers running flat chat. In between them, they have 100 meters of really big chain. Now, each link of this chain is so heavy that you struggle to lift one link. So that's how industrial scale clearing is done. And they literally rip the trees out of the ground. It's a very effective way of deforestation. None of this timber is used. It's all pushed together and burnt. But this gives you an idea of how this was invented in Australia, this tree pulling, as it's called, between 2 crawler tractors initially back in the 40s and 50s. But now you get the big dozers, and it's very effective. These bars that the dozers have out in front of them, they're called tree spikes. and they can actually come up against a big tree if they can't rip it with the chain, and they push it up and over, and it literally snaps the taproot to get it. And okay, this is in Florida, and that gives you an idea of the chain, the size of the chain. These are D8 doses, so they're 50-ton doses. And this is in Brazil. So you can see that these methods are used right around the world because it's so efficient. It's so effective at ripping down forest. And here's a bit of history. As I said, this method was invented in Australia, and originally they didn't have such big bulldozers. So what they did is they had a ball in the middle that lifted the chain off the ground a bit, gave it more leverage to pull over the trees. So this is how it was done back in the 50s. And yeah, after the war, the soldier settlers were given land. So this is how they cleared it. This is from a video of Western Australia, where they cleared forest, and what you saw just there was a drip torch. They use these still out of quad bikes or out of helicopters to burn, and then you stick rake it. You rake all of the dead wood together and burn and burn and burn again, and then you can plant. And in Western Australia, they did that, and but then it dried off, and terrible degradation like you had in the States. Anyway, this is a picture of global fires. This is to give you an idea of the fact that the world is burning everywhere around the world. Fires are lit in the dry season for a number of reasons. The first one is deforestation, and the second one, which covers a bigger area, is actually pasture management fires. And as you'll see in Africa, that's the main cause of fire over there. You can see north and south of the equator, as the seasons change and the dry season comes in, they burn it off. They burn off the long grass to kill the old dead grass, and which is unpalatable, and make the new green pick come through. And they also burn to get rid of the ticks. So, but the main use of that fire is to kill off any regrowth forest. They call it woody weeds, and it kills off the woody weeds. So this is an idea of what happens around the world with deforestation. And these are the deforestation fronts: South America, Africa, Australia, and Southeast Asia. And that's 2 10-day pictures of the dry season north and south of the equator. So you can see that the world is on fire because of this. And of course, it's very unhealthy. So that's where I'll stop this particular video, because that just gives a bit of my background for this. But this slide here is really interesting because we have so much data on deforestation now. The estimates are that between 88 and 99% of deforestation is for agriculture, and at least 70% of that is for animal agriculture. So logging, this is a persistent myth. Logging does not kill forests. Food kills forests. And the way they do it is with fire, which I just ran through. So if you log a forest, if you cut down all the trees, almost clear felling, and if you leave it alone, that will be forest once again in time. And it only takes 1, 2, 3, 4 decades. But to turn that forest land into something else like grazing land or cropland, you need to burn and cultivate and stick rake, as we saw. Okay. Okay, so this is a story about how we can restore the environment and feed the world. Okay. Can you see the next slide now? Great. Okay. Many of you have heard of the concept of human footprint or ecological footprint. And the WWF puts out a report each year that looks at how we are going. And at the moment, we are consuming 1.7 times as much as the Earth can sustainably produce. In other words, we have overspent on the credit card, way overspent. And if we all lived like North Americans or Australians do with our consumption, we would need 5 planet Earths to support that consumption globally. So what does that mean? What does that really mean? And this chart says it all. The Stockholm Resilience Centre have been working for decades now with teams of scientists on what are the systems that support life on Earth? How are we going against those systems? Are there limits? Have we overstepped them? And these are called the planetary boundaries. So they've defined 9 separate areas of, if you like, life support systems and how we have overstepped or not. Some of them are still unknown, as you see on the right-hand side with the question marks. And the zones that are in the yellow and the red, we have overstepped the mark. What's still in the green is still sustainable. So by definition, if we overstep any one of these planetary boundaries, we endanger all life on Earth. So we've overstepped a lot of them. But there are solutions, and I'll get to those soon. But what I want to point out in this diagram is that the black dots represent the space, if you like, of that planetary boundary, the safe that's taken up by agriculture. So the black dots are the major part of many of these planetary boundaries that have been overstepped. They call it biosphere integrity here. That means the sixth mass extinction, the loss of wildlife on planet Earth. Land system change, that refers to deforestation. Freshwater use, we know what that is. And biogeochemical flows, that means that's basically nutrient flows, and it's nitrogen and phosphorus, and we've way overstepped those. So that's what ends up in ocean dead zones. So I'll come back to some of those, but you can see there that agriculture has the greatest part of our footprint on planet Earth. It's not iPhones, it's not plastic waste, it's agriculture. So that very firmly places agriculture front and center. And what I'm about to show you is how animal agriculture has the greatest part of that footprint by a long shot. So it's well studied and well known that global food production is the single largest driver of environmental degradation and transgression of planetary boundaries. You don't hear about this much. You hear about many things that cause the breakdown of the systems that support life, but you don't hear that our food is the major contributor. Just to run quickly through the distribution of mammals on Earth. Many people say, well, you know, we used to have millions of bison roam the plains in North America, for example. But what I'm about to show you is the current distribution of mammals. Mammals are the ones that warm-blooded, they have children. So this is a diagram. Humans make up 1/3 of the biomass of life on Earth. Our farmed animals make up 60%. So when people say, you know, we've got too many mouths to feed on the planet, we've got the population is a problem, it's not the population of humans, it's the population of farmed animals. And because the farmed animals are all youngsters, babies, teenagers, they're bred to grow as fast as they possibly can. Their lives are cut short to the minimum when they're slaughter weight. They're ravenously hungry. They're bred to be ravenously hungry. Pigs, for example, put on 1.7 kilograms a day. You know, and that's why they produce 5 times more effluent than we do. But what my point is that even though farmed animals are twice our biomass on Earth, they produce 5 times more waste as we do, and they consume 5 times more biomass, like crops or whatever their food is that we grow for them. So this is a little bit biased. Their impact is way and above ours. Pets, by the way, 1%. And wildlife, we've squeezed it into a corner so much that only 4% of the biomass is still wild. This is like from mice up to whales and elephants. All of them put together make up 4% of the biomass of life, mammals on the planet. So when you look at that, you realize that we've had this attitude, and it's not so long ago, my generation and the one before, the attitude was, we must develop the world. We must develop the world. We must tear down the trees. We must make way for agriculture. We're feeding the world. We're feeding our family. We're feeding our community, and we're bringing prosperity to the world. This was the attitude. And now what we've done is we've got to a point where we have taken so much of the so-called natural resources that it's coming back to bite us in many ways. Climate is only one. Biodiversity loss is perhaps the next greatest threat to life on Earth. And it's now well known that cattle farming is the greatest driver of biodiversity loss. And 80% of agricultural land is devoted to livestock and feed for animals. You see in this picture on the right-hand side, this is Brazil. And they made way for soy crops in this case. And what the point I want to make is that when we take away habitat from wildlife, they don't just get up and move next door, they die. Habitat is everything for wildlife. You know, that you hear wildlife is territorial. Well, it's for a reason. That is their patch. That is the food system that supports their life. And by moving into someone else's food system, they're not welcome, because that's their life support. So when you take away habitat, you take away life. And that's the reason why we have destroyed biodiversity on planet Earth. That's the reason why we've squeezed wildlife into this corner. And when you squeeze wildlife, take away their habitat, they get really stressed. And the stress levels make their viral load shoot through the roof. So these viruses are so easy then to transfer to humans, and that's what they're doing. So deforestation, we know well that the leader in deforestation is Brazil, and it and the other countries around, 84% of that deforestation is for pasture and livestock feed. A paper came out a few months ago that said that, look, if we source zero deforestation beef properly, not just JBS's method of shrouding the figures in secrecy, but if we do it properly, we could cut Amazon deforestation in half, and that matters, and I'll show you why in a minute. Nutrient pollution, we spoke about that before. It's called the main pollution, environmental pollution globally. It's the biggest problem of pollution, air and water pollution in the world. And what it ends up is dead streams. You see the algal blooms, the green flushes, they're everywhere. It's because the nitrogen, because of the phosphorus, because of the nutrients that we're pouring into the natural systems. And wherever we have factory farming, for example, where we're feeding chickens, all that grain is imported. So from another country or from somewhere else. The chickens eat that, and their waste is concentrated. So whenever we have a flood, and that waste gets into groundwater, etc., that's where it starts, and it ends up as ocean dead zones, permanent ocean dead zones. But the open oceans now are starting to lose their oxygen as well. this is recent studies, so that's extending globally now, and this is a cause for major concern because hypoxic oceans have been linked with past mass extinctions. Water, as you know, actually the Colorado River is a good example of this. There was an outcry about how almond nut production was gulping up so much water, or people washing their cars. But there's been several studies done on it now that shows that 50% or just over 50% of the Colorado River withdrawals have been for either pastures for dairy or for crops to feed animals. For example, there's an export industry in growing alfalfa, and they are growing 3 crops per year. They were pouring on so much water they could do that. Alfalfa is a grass, grows quickly. You can harvest it 3 times a year. So this is incredible, efficient production, but wow, heavy on water. So, you know, half the water of the Colorado River is going in animal feed for the animal agriculture. That's not discussed, you know, that we talk about almonds, which is rather strange, but we all know that animal foods are very heavy on water use. You can see there a potato takes 25 litres, a burger takes 2,500 litres. Okay, ocean ecosystems, we touched a little bit on the documentary in this, but we've wiped out 90% of the fish we eat. And bottom trawling has ploughed the continental shelves. It's destroyed ecosystems globally in those unprotected areas. Even the protected areas are getting bashed again. But because the industries rely on it, there's a lot of money put into fishing industries, and it's getting further. It's a useless thing. This is a this is a really interesting story here. This is the Global Ocean Commission. They were commissioned to report on the sustainability of fishing some years ago. They put out one report and they were immediately disbanded. But this is one example of what comes out of that. You can see that since the 1950s, our fishing capacity has grown by 63%. The ships are bigger and they go further, but the amount of fish available has dropped 87%. So this is a classic example of the folly, the absolute foolishness of humanity. And regarding climate change, we now know that food will cause 1.5 to 2 degrees warming, even if carbon dioxide is cut to 0. That's interesting. Ask anyone and they'll tell you that fossil fuels and carbon dioxide are the main cause of global warming. But as we'll see in a minute, that's not true. Methane is the largest impact. Okay, what I've got here is some touching on some new research that hasn't been. Oh, okay, sorry. This has been published, this one. So I'll briefly talk about that, and then I'll go into the new research that we're doing. A paper came out last year that said that there's new ways of assessing what's changing climate these days. The last IPCC report came out a couple of years ago, 2021, and they looked at a new measure called effective radiative forcing. Now, this is, they've had that term before, but they've used it and related it to emissions. So it's an emissions-based effective radiative forcing. And what that does is they've looked at the atmospheric chemistry again, and they've seen that methane, for example, when we emit methane, it has this downstream effect on many levels. It creates tropospheric ozone, which kills crops and causes global warming. It creates water vapor, which forms clouds at the wrong level. It creates other downstream gases and effects as well. So if you wrap all of these other knock-on effects, you find that, and if you look at fossil fuels with its cooling, see, when we burn fossil fuels, we don't only release carbon dioxide, we also release sulfur dioxide. And the sulfur dioxide is so strongly cooling that it's balanced out the carbon dioxide. So up to now, this study said fossil fuels have caused 20% of global warming, and most of that comes from methane. This, if you were a government responsible for looking after climate change, you'd think this would turn a few heads, and it will. I'm sure that this will in time. They also found that methane has caused half of global warming, just over half a degree centigrade. So the people who are trying to downplay the role of methane in global warming, this is a real wake-up call. By the way, that 20% of global warming from fossil fuels, that will increase into the future unless we control carbon dioxide, but we do have a control for that. We'll talk about that soon. And since 1750, vegetation and the oceans have removed more than fossil fuel has released. So the biosphere is incredibly powerful. We haven't recognized the power of the biosphere solution. And this is being studied again and again now, and we're getting, this also has been enabled by recent science. You see, at the moment, previous to this, the biosphere, the vegetation and the soils and how that related to atmosphere, that was pretty much unknown. It was a black box. So when they developed the IPCC rules, they decided to take the net output of that black box. They didn't look at the details, which is the gross emissions and drawdown. They looked at just the net output, whereas with carbon dioxide from fossil fuels, they looked at the gross output. And this, you'll see in a minute, is a fundamental flaw in current accounting. But now we know that the biosphere has a huge potential to draw down and it's been working that way for a long time. See, we've been doing deforestation for 10,000 years. And up until 1750, the atmospheric carbon dioxide level hadn't changed. So we've been doing all this deforestation. Why hadn't that changed? It's because the rest of the vegetation was working overtime to balance out the human impact. So the biosphere is a self-correcting system. It was only after 1750 that the biosphere just couldn't cope with all this extra CO2 from deforestation and from fossil fuels. So the bottom tan colour area is the cumulative deforestation emissions. And you can see the proportions changing to the present, but in the past, by far, the greatest emissions came from deforestation. And here's a slide from a work I was doing recently on regenerative grazing. Boy, isn't that a marketing coup? But this shows on the left-hand side, this is the potential, that blue bar that you can barely see, that's the sequestration or drawdown potential for grazing soils. The next bar is the drawdown potential for crop soils. Crop soils are much more degraded than grazing soils because the grazing soils, grasses, stay there from year to year to year. Crop soils, we rip out the plants every year. So that's the potential on the crop soils. They've been degraded. But the potential for forests on grazing land is enormous in comparison. And that's transformative, that level. That's decades of emissions, more than what's in the atmosphere right now. So that's the potential. And just for fun, I measured the potential of forests on built-up lands, which is that bar to the right-hand side. So even though we might think that cities spread everywhere, they only actually cover 1% of the land. So the potential we have for example, forests on grazing lands, grazing lands cover 37% of the land. It's our biggest land use by a long shot. So that's that. And we've known for a long time that rewilding grazing lands is the lowest cost, largest scale natural solution to climate change. And a lot of organisations are working on this now. The reforestation is always number one at the top of the list of Project Drawdown, for example. Project Drawdown, number one is reforestation. It has so much potential. But the trouble is that scientists around the world, when they're investigating these things, they don't believe that we could change that much land use. You see, George Monbiot, he's recently written a book called Regenesis. And Regenesis is a fascinating book. I can strongly recommend it. In that book, he says that if aliens were to visit the UK, they would think that the dominant life form was sheep. And the reason for that is because they take over most of the land. So what would you think is our most precious resource? I mean, other than our families, they're very precious to us. What else is precious to us? Water, yeah, natural resource, yeah. What about land? Land and country and our ecosystems, are they not precious to us? And what are we doing with that precious resource? How are we using that? Is it a good use for that? Well, if you look at grazing lands covering 37% of the planet, what do we get from that? We get red meat, or some red meat, and some dairy. In fact, they've run the numbers, and of the animals that are exclusively grass-fed, we get 1% of our protein. Of the animals that are partially grass-fed and partially lot-fed, which is the majority of beef in the world, we get about 5% of our protein. So from the grass, we get 5% of our protein. Now, how wasteful is that to squander 37% of the planet for 5% of our protein when we could be turning that land back to nature, back reversing climate, reversing biodiversity loss, reversing the breakdown of water cycles, etc. So farmed animals give us use 43% of the land, including the crop area, but they give us by dry weight, this is IPC work here, they give us by dry weight 12% of our food. IPCC science is good science. The real reports collate all the latest research and put it together in a pretty good form, but only scientists can really read it. And then they make these summaries, these summary for policymakers, which are political documents. So when people criticize the IPCC reports and say that they're controlled by the industries, that's true, but it only applies to the summary for policymakers. When you go back to the science in the IPCC reports, it's all good science. So you've got to discriminate a little bit in criticizing IPCC reports. So if you look at farmed animals, 43% of the land, food crops, the crops that feed us, they take up about 6% of the land, and they give us, by dry weight, 85% of our food. So most of our protein now comes from plants, not animal agriculture. And we know a vegan diet can reduce land use by 3.1 billion hectares. In other words, we can free up Africa back to nature. Wouldn't that be nice? Many organisations have studied this, and this is from WWF, but it points out that globally we need to reduce our consumption of meat by 75% if we're to be sustainable. So in heavy meat-eating countries such as Australia and North America, that equates to a greater than 90% reduction in meat consumption to meet the sustainability level. And I love what Jonathan Foley, he's the head of Project Drawdown. He says that things happen very, very, very slowly and then all at once. So that's what I was talking about before. That's how much food we get from ruminants. The biomass of farmed animals. Oh yeah, this is the bison roaming the plains. There might have been millions of bisons, but now we've got hundreds of millions of cattle. So this is it in a study. This is wild animals 10,000 years ago compared to farmed animals now. So there's no comparison. We have loaded up planet Earth to the point where it's at breaking point. And the only reason, by the way, we've been able to do that, how have we increased the biomass productivity of our planet? Well, it's through the miracle of nitrogen fertilizer. And we literally pull that out of thin air. So through the green revolution, we have been able to increase the productivity of our planet dramatically. And what's taking the bulk of that productivity? Produce is farmed animals. It's not a natural cycle for animals to do that. It might be in small numbers, but when you have hundreds of millions of these animals, it's way beyond sustainability. Animals and their waste are responsible for more methane emissions than anything else. And the next methane producer is fracking. It's fugitive emissions from coal and from gas production. They say gas is a great transition fuel. It's such a nonsense because there's so much leakage from that system and that's methane basically, so much leakage that we know methane's a major cause of global warming now. So that's a problem. Plus the cattle that roam the surface. And one issue that is often raised is, in the third world countries, cattle are needed as a source of wealth and for feeding their young and for income. Well, since the mega droughts that they've had in Africa, we've seen that that's no longer the case. Their wealth in that four-legged animal can evaporate overnight. And there's no social security systems to help these people. They depend on that. There are programs where they've I think it was about 10,000, even Maasai, the traditional herders, the Maasai have been given land, whereas they roam the common land. Now they have land and they're able to produce much more water efficient crops and also cash crops like aloe vera. So they're prosperous once again, even in the droughts. Manure for fertility. This is the premise of the Kiss the Ground documentary. A lot of it is good, but they do say that we need animal manure for fertility. Well, when I heard that, I laughed out loud. The greatest pollution on Earth is caused by animal manure. So for us to think that suddenly this is going to become a wonderful thing for our soil, it's such a joke. When you have floodwaters, some of you have experienced floods recently, and the authorities always say, do not enter floodwaters, they are toxic. And the reason they are toxic is because they're loaded up with salmonella and so many other toxins from the effluent ponds that come from farming. You see, as I said before, the effluent from farmed animals is many, many times our effluent. And there'd be a public outcry if our effluent were not treated properly. Public outcry. But there is absolute silence around 5 times as much effluent that is not treated at all. It's just in ponds, and that leaks, of course. When it overflows with rain, of course, it's a disaster. So this is the problem. That animal manure is not a solution at all. Okay, so to set the scene for the recent research that we've done requires a global look at forests and the carbon as it's shared around planet Earth. So 10,000 years ago, the world had 6 trillion trees on it, and right now we've got 3 trillion trees left. This is even with the of course we've cut down more than 3 trillion, but these are the trees that are there now, the ones that have regrown. So yeah, this is how we began with axes, and as I showed you, now the industrial scale deforestation is with dozers. If you get into the thick, dense rainforest, it has to be individual dozers, and they first drag out the logs. They cut the trees down first. Oh, sorry, wrong way. So what I want to tell you is it's hard to kill a forest. Nature is ever ready to come back. And the way we suppress nature is twofold. We burn, as I showed you, we burn and we burn and we burn again. The world is on fire. And we also have this magical property of ruminants, particularly sheep and goats, but cows are pretty good at it too. They can nip in the bud any regrowth tree. So I recently went, a dozen years ago, we went to the Scottish Highlands. Now, Scotland used to be called Caledonia, which means forest, but now it's a moonscape. But it's beautiful. But it used to be covered with trees. So why have no trees come back? Why has nature not reclaimed that land? Well, it's because of the sheep, basically. Sheep are amazing. They have this superpower. If any little sprout pokes its head up, gone, bang, it's gone. So when they do reforestation projects, as they are doing over there now, they've got to fortify the areas either in very thick sheaths to a certain level so the sheep can't get up to them, or fence it out really sturdily so that the ruminants can't get back in. So what we've done, the sheep in that sense have been the greatest force for geoengineering that we've invented. It's amazing. And alongside with forest, they rank right up there. But if you take away the sheep and you stop burning, it comes back. And one way to spot how if a forest is regrowth is exactly this. All of these trees are the same size. So in other words, this area they've come through and it looks like they've clear fell. They've taken out everything, probably for wood chip, for paper, or for timber, for my home, amongst others, and then left it alone. And what happens is that nature bounces back so quickly, but you can spot this a mile off because all the trees are the same size. This is a bit of my history. I worked on the Beyond Zero Emissions land use plan that became too hot for them, so they called it a discussion paper. This is because I found that Australian animal agriculture causes half our emissions. They didn't like that, so they buried the report. But this is what we're working on now. This is what I wanted to get to. What I've been harping on about is forest all along. It's all about forests. The climate on Earth, the biodiversity loss, it's all controlled by the forests. So this is what we find. This is what we found, and it's so plain and clear and obvious that it's been accepted this way, and this is what's accepted. There are two main sources of carbon dioxide: fossil fuels. We can count fossil fuels really well. We know how many litres of oil are taken out of the ground. We know if we burn that, how much carbon dioxide it'll produce. And the other source of carbon dioxide on the right is deforestation, which we've been doing forever. And that was hard. We didn't know exactly how much that released. But what we did know is the net release of that, the amount of, after we subtract the carbon dioxide soaked up by regrowth on other land, we have this net amount, and that's what we count as the deforestation emission. Now, this is an IPCC report convention. It's, if you like, 30 years ago they developed these, but it's a convention that, you know, they made the rules so that every country had the same set of rules and they could define their own country emissions, so they could then measure how are we doing. This is all very good, but this accounting, where we have net accounting for deforestation and gross accounting for fossil fuels, this has been accepted, you know, broad daylight, everyone sees it. This is just the way we do it. But the problem with that is it's introduced some huge discrepancies, because this is what happens to carbon dioxide gas when it's released. In fossil fuels, some of the carbon dioxide ends up in the atmosphere. Most of the carbon dioxide that same year is absorbed by vegetation growing. Now, what we've done is, because we've got CO2 fertilization, it means that trees grow bigger. So the carbon, lots more carbon dioxide is being soaked up by the trees. Okay, on the right-hand side, same story. When we deforest, some of the carbon dioxide is released into the air, but most of it is drawn down by existing vegetation. So both ways, most of the CO2 is absorbed by growing trees. But this is how we count for that. On the left-hand side, fossil fuels, all of the CO2 is counted. On the right-hand side, deforestation, we only count about a third of it because of these rules, because of how it was developed 30 years ago. Well, now we know better. We have vegetation models and we have much more information on the biosphere carbon dioxide flows. So why does this matter? It matters because when we look at historic greenhouse gases, we find that deforestation has released 4 times more carbon dioxide than fossil fuels. How about that? And fossil fuels are a minor cause of global warming. How about that? So trees determine climate on Earth more than anything else. Fossil fuels are up there right now. The mix is now more fossil fuel emissions than deforestation. But that's only in the recent few decades. Up until then, 4 times more carbon dioxide has been released by deforestation. So this is a graph of that. This is the IPCC's conventional system. This is how we all the scientists, and these are not, I'm not poking fun at scientists. I'm not saying you're wrong. There's hundreds of dedicated, incredibly talented scientists been working on this, but it's sort of the flaw right in front of our nose that we've missed. But this is the conventional treatment. We graph the emissions from fossil fuels, which is the brown area on this graph. And as you can see, it's been increasing. This is a cumulative emissions. So adding 1 year to the year before. And as you can see, the emissions from fossil fuels are ramping up very quickly. And this is what and the green area on the graph is the deforestation emissions. But you see, this is what we measure, which is the net emission. So this is how we've been looking at climate up until now, with the brown compared with the green. And sorry, on the left-hand graph, most people would say, yes, okay, fossil fuels dominate. Deforestation is secondary. But if we do the accounting the same for both, the graph on the right is what we see, that emissions from deforestation are way more than from fossil fuels. And what's left in the atmosphere is just this small amount up the top here. So you can see that what's happened over these 10,000 years is that nature has been working flat out to balance our excesses. And it's only in the last 2 centuries out of 10,000 years that nature has been unable to keep up with our emissions. But you can see that fraction that's in the atmosphere now, that's only a small fraction with the amount of deforestation emissions. So this gives you some concept of the power of nature to both cause climate change and to draw down, and the cumulative fraction that we're talking about, which is only small in comparison. So this tells you, this lets you seek for a solution in the biosphere, not in fossil fuel, as well as in fossil fuels. So deforestation is released 4 times more. Therefore, and what we're doing with this research is looking at what are these sectors, what are the industries that have the greatest impact on climate? In other words, what are those industries that have caused the most deforestation? And of course, animal agriculture taking up 37%, 43% of the planet, it's the leader by a long shot. Yeah. So our figures are showing that animal agriculture has caused about half global warming, 0.6 of a degree. These figures aren't verified. They're not peer reviewed yet. We probably released this as a preprint, but we've got to go through a big process to publish this in a journal. So treat this with a grain of salt. The reason animal agriculture has caused so much climate change is directly because of its deforestation impact. And we find that methane has caused nearly half of global warming, similar to what the previous study that I looked at. So those people who are trying to downplay the impact of methane, this has got to stop that in the tracks. Here's some charts that we produced. As I said, take these numbers with a grain of salt, but this is looking at 4, 5, 6, 7, 8, 9, 10 of the top 10 emission species, which start with carbon dioxide, methane, nitrous oxide, etc., etc., etc. And we looked at the effective radiative forcing from these, which is now available from the IPCC, and we matched those against industries. And we find that if you look at the colourful bar on the far left-hand side, the 0 is in the middle there. Okay, so that's no effect on climate. Above that line, you can see the biggest impact is blue, which is carbon dioxide, and then above that is methane in the brownie colour, and the other gases on top of that. The halocarbons have a big chunk of that. But beneath that line, you see the grey area, which is sulfur dioxide, and others like nitrogen oxides and organic carbon below that line actually cause cooling. So fossil fuels have released all these emissions above the line that cause warming and the cooling from below the line. So when you subtract one from another, if you look at this grey bar shape on the right-hand side, you see that's the net impact of fossil fuels. So fossil fuels have caused way less than other sectors, and the other sectors are so large because of the land use impact. I won't go through, there's a lot of data there, but what I wanted to point out was that it's all about trees. It's all about forests. Fossil fuels are a minor part of warming up until now. Fossil fuels are now in our face. They're greater than deforestation. But knowing the huge power of vegetation, we can deal with that. We can make carbon dioxide a short-term emission. This also, by the way, it levels the divide between north and south. A big focus of climate talks up until now has been the less developed countries looking at the most developed countries and saying, but you've been emitting emissions for centuries. We've only just started. How come we're expected to bear the burden of this climate change? And this way of looking at that actually levels that divide because, for example, at the moment, all eyes are focused on Brazil to decrease their deforestation. But that criticism is coming from developed countries. So countries such as mine, such as Europe, such as North America, they've done their deforestation a long time ago. But this levels that divide. It shows that past deforestation and current deforestation together in this graph. So we can't point fingers without pointing it back at ourselves about the deforestation that's been caused in our own countries. Oh, and there's this other really interesting concept called carbon opportunity cost. And that is a measure of remediation, it's a measure of drawdown. We are now entering the age of drawdown. We've got industries built on carbon offsetting, and most of those carbon offsets are trees. So you've got this, every industry is looking at how do we go green? How do we become carbon neutral? And it's all through offsets. And these offsets are in the form of trees. I mean, that's a wonderful natural thing. But this is allowing them into the equation. Okay, what is the potential of every bit of land to soak up carbon? So we can look at, and this has been well studied, the opportunity cost of all the land around the globe to revegetate that. What's the potential there? How much can we draw down? And if you add that potential, like the land taken up by these industries, animal agriculture, because it's so land hungry, it dominates the planet, therefore it dominates the carbon opportunity cost. Next is crop agriculture for food, for fiber, etc. And as I said before, the cities, the built up areas, they're only a minor fraction. They only cover a small part of the land, 1%. So it's not that we need to rip up driveways and plant trees. It's that we need to look at what we're doing with the bulk of land on planet Earth, and that is grazing cattle and sheep on it. So animal agriculture, while it has the greatest impact and has had the greatest impact on deforestation in the past, it also has the greatest potential, same coin, it's two sides of the same coin, to reverse global warming. And fossil fuels have caused less than 20% of warming. So my conclusion from this presentation is that rewilding, and this is Scotland, by the way, this is an area of Scotland where they have rewilded. Rewilding actually solves humanity's two greatest environmental crises. The sixth mass extinction, which is worse than we think, and the solution is habitat. And this is a half-Earth project, as you may have heard of, to return enough land to nature, enough habitat to nature to give it a chance. And so returning grazing lands will certainly do that. And secondly, the climate crisis. And the pictures on the bottom of that screen is the face of climate crisis for the future. Refugees. We're going to see this more and more. At the moment, there's for the last 15 years, there's been more than 20 million refugees per year. Most of them stay within the same region, although they might move country, they stay within the same continent. Some of them leave and go to another continent, like that crisis we had in Europe. where all the Syrian and so on refugees ended up there. They had no food for the family, so what do? Imagine you were in their shoes. You'd hate to leave your country, your homeland. You'd hate to leave the farm that you've been working on for and built up, and the house that you had. It would take a lot to get you to move to another continent, but they have to, because there's no food, there's no water. So this is the face of climate change. And of course, that brings conflict with it. We know that with enough land carbon sequestration, we can solve the climate crisis once and for all. So rewilding grazing lands, both of these are Scotland from my own picks. Rewilding grazing lands can and ending deforestation will reverse global warming, no question. So the two most urgent crises on Earth are solved by this one move. I'll go through these. Joni Mitchell, who doesn't love Joni Mitchell? She said, "Don't it always seem to go that you don't know what you've got till it's gone?" Well, it wasn't paving paradise, it was actually grazing paradise. That's caused the problem. So we need a new vision. And we've got to realise that the climate disaster is human-made, not cow-made. And we can share this precious planet. All life can prosper. It would be humanity's greatest achievement. This was the grandfather of biodiversity. He died last year, sadly. And Oren Lyons says, nobody owns the woods, but everyone is responsible. So every square foot, every acre of land, every tree, every shrub, every grass is precious and crucial for our survival. It's a big mindset change, but we'll get there. And as Salish Rao says, are we collectively desperate enough to contemplate lifestyle changes? And, oh, I've got to show you this. My daughter-in-law had it made for my last birthday. I don't know if you can see it, but this is eat plants and plant trees. So that's the message. Thank you.